Here's another example. Again, I probably want to switch these, so I want to pivot these columns. So I'm going to change, say, equation 1 with equation 2 so that I have a nicer value to work with my leading term. 2x plus y minus z equals 4, and x minus 2y minus 2z equals 1. Now, we want to eliminate these x's so we can start on echelon form. So I need to take negative 2 times equation 1 and add it to equation 2 to get a new equation 2 that doesn't have an x in it. And I can just subtract equation 1 from equation 3 to get a new equation 3 that doesn't have an x in it. So leaving my latest equation 1 alone, and negative 2 times equation 1 plus equation 2 would be no x's. Negative 6y plus y would be negative 5y. Negative 2z and negative z make negative 3z, and negative 6 plus 4 is negative 2. And then I was going to take negative equation 1 plus equation 3 to get a new equation 3. That's basically subtracting equation 1 from equation 3. X minus x is nothing. Negative 2y minus 3y is negative 5y. And negative 2z minus z is negative 3z. And 1 minus 3 is negative 2. I can see that the third equation now is the same as the second equation, which means the third equation was actually dependent on the first two. It can be built from the first two. Or you could continue on here and just take negative equation 2 and add it to equation 3, because that's what it would take to get rid of the y's, and use that to replace your equation 3. And you see you get the system x plus 3y plus z equals 3. Negative 5y minus 3z equals negative 2, and if we do our subtraction here, negative 5y minus 5y is nothing. Negative 3z minus 3z would be nothing, and negative 2 minus 2 would be 0. So this third equation just turns into 0 equals 0. That just tells you that as long as the first two equations are true, the third one is always true. So the third one didn't really carry any new information. So since x is the head of the first equation and y is at the far left of the second equation, we'd say x and y are pivot variables, but z is not in a pivot column, and so z is a free variable. So let's let z be free. And if we do that, then we can solve for y. Negative 5y will be 3z minus 2, so y will be negative 3/5 z plus 2/5. Now knowing y in terms of z, we can solve for x in terms of z. X is x plus, the first equation says x plus 3y, and 3y would be negative 9/5 z plus 6/5. X plus 3y plus z equals 3. So x, let's see, negative 9/5 plus 5/5 would be negative 4/5. So x minus 4/5 z. If I move the 6/5 over, this is 15/5, take away 6/5 is 9/5. So x is 4/5 z plus 9/5. So we can see we have infinitely many solutions because we only have two planes. The third plane was just a combination of those other two, so it didn't really specify anything. So we have two planes, they meet in a line, and this specifies that line. Let's see, y is negative 3/5 z plus 2/5, and let's see, z can be z. Now there would be other ways to write this. It's possible, it's kind of convention to make the variable that's not in a pivot column be the free variable, but you don't always have to, although that is the safest course, because sometimes it doesn't work out if you let one of the other variables be free. If it's kind of disattached from the other variables, it can't be done. So anyway, there's a solution. If you pick a particular value of z, then you could plug it in and you could get a particular value for x, y, and z that solve that plane. But there are infinitely many choices for z, so infinitely many solutions. Let's do one more application. We have a triangle, and we're told the perimeter is 40 meters. The sum of the two shorter sides is 2 meters more than the longest side, and the longest side is 11 meters longer than the shortest side. Find the two sides. See, don't we need to find the three sides? Okay, so let's find the three sides here. So what we know is we've got a triangle. There's a long side, and there's a medium side, and there's a short side on this triangle. And the first piece of information is about the perimeter. So we know that if you take the long plus the medium plus the short, you get 40. We also know the sum of the two shorter sides is 2 meters more than the longest side. So if we take the two shorter sides, the medium side plus the short side, that's equal to the longer side plus 2 more meters. And the longest side is 11 meters longer than the shortest side. So the longest side is the short side plus 11 meters. And this is an equation in 3 variables and 3 unknowns. So we could solve it by using Gaussian elimination and back substitution. Let me rewrite my equations just a little bit nicer. L plus m plus s equals 40. And if I bring that L over, negative L plus m plus s equals 2. And if I bring this s over, L minus s equals 11. Let's just use we'll just use our Gaussian elimination. I'm going to take equation 1 plus equation 2 to replace equation 2. And while I'm at it, I'm going to get rid of this L by taking negative equation 1 plus equation 3 to replace equation 3. So when I do that, see, I'm not changing the first equation, so L plus m plus s still equals 40. But if I add equation 1 to equation 2, I get 0 plus 2m plus 2s equals 40 plus 2, that's 42. And if I subtract equation 1 from equation 3, L minus L is nothing. Nothing minus m is negative m. And negative s minus s is negative 2s. And 11 minus 40 is negative 29. Good. I'm going to multiply this second equation through by negative 1 just so that it looks a little cleaner. And then I'm going to divide this one through by 2, so I'll get 1m plus 1s equals 21. And let me recopy here. L plus m plus s equals 40. And now we have m plus s equals 21. And m plus 2s equals 29. Now let's go ahead and take negative equation 2 and add it to equation 3 to get a new equation 3, and we'll be in echelon form. So when we do that, not bothering the first equation and leaving the second equation alone as well, but I am subtracting the second from the third. M minus m is no more m's. 2s minus s is a single s, and 29 minus 21 is 8. Well, now I see the staircase, right? The escalator, the echelon form. And so I can read off that s is 8. Knowing that s is 8, I can back substitute to find that m plus 8 is 21. So that means m is 13. And finally, knowing that, L plus m, which is 13, plus s, which is 8, is 40. So 13 and 8 is 21. So L plus 21 is 40. And 40 minus 21 is 19. So the length is 19. So now we've figured out that this triangle must have longest side 19, medium side 13, and shortest side 8. Well, we could check by adding these up, make sure it works, right? 19 plus 8 is 27, plus 13 makes 40, so the perimeter is 40. The two shorter sides make 21, and that's 2 more than the longest side, which is only 19. And the longest side is the shorter side plus 11. So the longest side is 11 meters longer than the shortest side. So we've found the 3 sides here.